Everything is made up of atoms. And let's suppose this rectangle represents a piece of metal. And the dots inside it, the blue dots, represent the nuclei of the atoms, and then the little red dashes represent the electrons, little negative signs representing a negative charge. Now, metals have what we call free electrons. A typical piece of metal has a lot of free electrons. Most metals have a lot of electrons that are so loosely bound to their nucleus that they're essentially not bound at all. An electron might be free to wander all through the material and go from one atom to another. It is these materials that have a lot of free electrons that are good electrical conductors. If something is a good electrical conductor, that means that electric current can flow easily through that material. And in this case, the current is simply the flow of electrons through the material. There's very little resistance to the movement of the charge through the material. Not every material is a conductor. If you rub a balloon on your hair and get electrons on the balloon, they don't flow through the balloon. Plastic and rubber are very poor conductors. They're said to be electrical insulators. The opposite of a conductor is an insulator. Insulators do not allow electrons to move through them very freely. Insulators tend not to have a lot of free electrons, and any movement of electrons from one atom to another is very, very difficult. The electrons are more tightly bound to the atoms. Most materials are either good conductors or good insulators. There aren't many that are in between.
Materials with high electron mobility, many free electrons, are called conductors, while materials with low electron mobility, few or no free electrons, are called insulators. Here are a few common examples of conductors. Silver, copper, gold, aluminum, iron, steel, brass, bronze, mercury, graphite, water with dissolved impurities, and concrete. In general, metals are the best conductors of electricity. Insulators are glass, sulfur, rubber, oil, asphalt, fiberglass, porcelain, ceramics, quartz, dry cotton, dry paper, dry wood, plastics, air, diamond, and pure water.
Conductors allow electricity to flow through easily. Insulators do not allow electricity to flow through easily. Here we have a complete circuit. You can see that the light bulb is on. When we disconnect the circuit, the bulb turns off. When we bridge the connection using a conductor, the bulb will turn on. What about other materials? Once again, we start with an open circuit because our circuit is not complete. The bulb is off. When we bridge the connection using an insulator, the bulb stays off. Let's review. Conductors allow electricity to flow through easily. Insulators do not allow electricity to flow through easily.
Try out some metal if you want to conduct.